The elevator trim jackscrew and yoke is in with a pulley down here. This is a Dakota Cubs jackscrew and the double pulley and the yoke. I powder coated the yoke and the double pulley down here. I didn't get any in the grooves of the double pulley, but I powder coated them to help with corrosion prevention. Now this yoke has a zert back here on the back of it. I don't know how much good that's going to be. I don't know how it's got a 90 zert coming out of the back, and I don't know whether we'll be able to get to that to put any grease in it or not. It just doesn't seem like it's going to be that accessible, but that would grease the jack screw and the yoke itself. When I had the airplane built, the airframe built, I had them put a nipple or a bushing in here on this upper part, this upper bushing for a zert here, and so I put a zert in there to grease that upper bushing. I didn't know when I started this exactly how this thing worked. I didn't know about this lower bushing, but I could see it would be a problem too. There's really no way to get oil into it except for to run down that shaft, and it's just tough to get any grease or anything into that. That should have a bushing in, or a zert in it or something. Now the other thing that I did on here was the upper portion of this jack screw that turns in this bushing here. It's just turned smooth. I drilled a 1/16 inch hole through it, and there's a cavity in that jack screw, in the top portion of that jack screw. There's a pocket in there that's drilled into it, and I drilled a 1/16 inch hole from the outside into that cavity, and I think what I'm going to do is I'm going to pack felt in here in this pocket, in this bushing, and put oil in it, because water can get in this bushing and build up in that, and that could cause a problem with rust in that. I've had trouble with these before as they set over the winter with the jack screws freezing up, and have a heck of a time getting them undone. But the zert here will put grease in there, but I think I'll put a felt in there and keep that full of oil with felt in it, and that would weep into that bushing. There's no practical way of doing anything with this lower bushing. I thought seriously about reaming these out and putting bronze bushings in there, but they're just not thick enough of metal. If they'd been built with thicker metal on there, then you could ream them out and put bushings in them, or put bushings in them. I did have trouble with this when I first checked it out. These holes didn't line up very well, and I took a reamer and cleaned out the 5/8 inch reamer and cleaned out this upper bushing, and then run a bushing in it with a shaft with a reamer all the way down through, and kind of line bored between these two, and reamed out this lower bushing. And I was worried about this, that it wasn't going to work very well, because even when I pushed the jack screw in there, you had to kind of thread it in to get it into this lower bushing, and it was binding up and tight. But once I got everything in there, greased up and everything, with it all set up here now, it turns pretty freely. I don't see where that's going to be a problem at all. That turns real free, and it's greased up good once it gets to work, and it's just going to get better. Now the instructions from Dakota Cub say to adjust this jack screw so there's between 5 thousandths and 10 thousandths play up and down on this jack screw. I suppose I should go get my dial indicator and set that up, but right now if I push on this, I don't have hardly any play in it at all, any axial play. I don't know how much there is there, but I'll go ahead and get the dial indicator and set up on that, and then I can tighten this screw up to the point where we have between 5 and 10 thousandths play in that, and then put the cotter pin in it. Working on the trim system. Now this is the front trim control pulley, and it's been in for a while, and I just had these strings running through here to line everything up, to line the direction up, and to make sure I had clearance with the baggage compartment and interior panels and stuff like that. Well, I just put in this lower pulley here, and for lack of a better term, we'll call it an idler pulley. But this cable is a continuous cable, and as a double pulley is the main pulley here. And I guess some of the early airplanes had a single pulley on them, both here and back on the jackscrew, and the single pulley would have a tendency to slip under certain conditions, and I suppose with added horsepower and speed, although there's not a heck of a lot of added speed between this and the early designs, but added horsepower and stuff, it puts more pressure on the horizontal stabilizer, so it'd need even more torque to make it turn. So they put in this double pulley system here, and a cable comes in, rolls over one pulley, over the pulley, down around this idler pulley, back up over this second pulley, and then back to the back. Now, why they didn't just use a single pulley with a wide groove on it, and they could have made 2 or 3 wraps on it like a capstan winch, that actually doesn't slip hardly at all. That's actually would be as good a way of doing it as any, but that's not what they did on this. They've made this double groove pulley here. So anyway, we've got that installed. We've got the little idler pulley put in, and I've got the cables tied together into a continuous loop, so that to checking everything. And this one I've got clearance on here, just barely clearance between where this cable comes down and around this one, or actually it goes up and around this pulley and back out that side. Haji, what are you doing? Well, there's just barely clearance there, so it doesn't rub there. And we're back at the tail of the airplane, and this of course is the jackscrew that adjusts for the trim, for the adjusting the horizontal stabilizer up and down. This is the double groove pulley here, and it does the same thing. It's a larger diameter pulley, but it does the same thing as the one in the front. Got the cable coming in, goes around the top pulley, then comes back over here around this idler pulley, and this idler pulley is attached with a spring onto the airframe, so that gives the tension on the cables. It comes around that idler pulley, goes back around the bottom groove, and then comes back out the bottom groove and goes back the other side. Now I was having trouble with this one getting it lined up, because where these cables cross right here, they both go on the bottom groove, and where they cross, they were rubbing, and I had worked on that quite a bit to get it to quit rubbing. When I first got this, I knew this was to hook onto the spring here for this trim cable and this tab that's welded on here, but I forgot that as I was working on the airplane. When I run this cable here for the ELT antenna, I put a clamp here on this tab to hold that antenna cable, and it was nice and neat and everything looked really good, but then I realized that that was the tab for this spring for this trim. So I took that off and put another clamp over here on this little cross tube here, and got that cable suspended there, and it's still nice and neat and it's out of the way. But I got the new spring, a new bracket and everything, hooked the new pulley up for this, and hooked everything up, put that spring through that tab right there, and when I did, then this cable was rubbing where it crossed, and it didn't make any difference what I did with it, how I routed it, whether I put this cable on top of this one, left it underneath it. I bent this tab down trying to get some more clearance on it, it still rubbed. What I finally wound up doing is putting an eye bolt in there and dropping that pulley down that spring mount down, a little over an inch, and then that gives me a little bit of clearance, just enough clearance here between these cables that they're not going to rub. There's no way to put a rub strip or anything else in there to keep them from not chafing, because this cable has got to move quite some distance. It's a pretty good sized pulley here on this trim tab, on this trim, and I don't know what the pitch of this thread is here, approximately 4 or 5 per inch or something like that. So it's got to move quite a bit of cable around there to move this trim up from one extreme to the other. So there's a lot of sawing action going to go on there, and there's no way you could put anything in there to between those two cables to keep them from rubbing. that looks like the solution for now. This is just string on here now, just to check on the cable runs, making sure everything's clear. Doing it with this makes it a lot easier to try to get everything lined up the way it's supposed to. I'll put this bracket on, and this is this string on here. This is for the trim indicator. It's not a control cable, it's just an indicator cable, and this would tie into the link tube, or the horizontal stabilizer link, and goes up and down with it. And then there's just a solid wire that runs up through this pulley and goes forward to the trim indicator. So it's a non-critical part, but we still want it to function properly. It's got this great big pulley. This is the same size pulley as all the rest of the control pulleys in the airplane, except for these little trim tab pulleys here. This one just uses a number 4 screw in it instead of a number 3 with a bushing in it to make it turn. So I'm not sure whether that thing is even intended to turn freely all the time or not, but there's no bushing in it. It just turns on the bolt shaft. And I know the other one was froze up, but it's just a cable just slides on there. There's a pretty good turn of direction there as that goes more than 90 degrees, and it also changes angles laterally, sideways, so this cable rubs on this pulley right here on the side. So these trim cables come from the Jackscrew forward. There's a couple of pulleys there just in front of the Jackscrew to separate them and to keep them lined up. And then there's tabs welded onto these side of the fuselage here with the pulleys on them that straighten them out and run them down the length of the fuselage to the forward Jackscrew. There's also a tab welded on right here for a fair lead for that indicator wire to go through. But as this indicator wire came back, it would rub on the bottom of this extended upper baggage compartment. So I put a cable clamp in there with another small fair lead in it, and screwed it onto the bottom of this floorboard of this baggage compartment. The airframe that they were building at Airframes Alaska, when we picked this fuselage up, they just cut a piece of square UHMW or Teflon stock and riveted on the back of this baggage compartment and hung it down with a slot in it for that to run through. But I think that's a number 8 AN 742 clamp, and that trim wire changes direction there and then goes on up to the pulley back there. Well, I've done a little bit more testing on this rear trim system back here, and I found that if I run this cable coming off of this idler pulley over the top of this cable where it runs forward into the fuselage and tighten the tension up pretty good, make the spring work a little bit on this, that I would get clearance on the top of that between those cables. Well, I did that, and then I went ahead and tried something, and I used this eye bolt and put in there, and that eye bolt raises that up about a ½ an inch off of that tab. That gives me plenty of clearance now on this cable back here. Okay, there's where those cables cross. You can see that gives me almost a ¼ an inch clearance right there now. So they're not going to rub at all now. That's a lot better. I'm a lot happier with that. So there's the eye bolt put in, and you can see how much that raises that up off that tab. That gives me a heck of a lot better clearance between those wires there like that. I'm a lot happier with that. It was just too close the way it was, but that gives plenty of clearance there. So those wires, there's no chance of them rubbing on each other when you're working that trim or when the airplane's flying. I took that eye bolt out so I could get some bolt, a nut for it, and a couple washers. And since that's a CAD plated bolt, I went and got some CAD plated washers and a nut. Anyway, I hooked this back up into that tab just to check it, and there was a little bit of clearance between these wires here, but it's like a 1/16 of an inch or less, and just not very much, considering that that's a horizontal span there crossing. And so any little bit of, if it warmed up or something like that, any vibration or anything would make it vibrate up and down and contact and cause wear. And I just wasn't comfortable with that that amount of clearance. If it had been a vertical clearance like it is on the front on the crank, it's close up there, but again, it's a vertical clearance, and there's less chance of it rubbing on there from gravity, vibration. So I went ahead and put this eye bolt back in there, and I put some Gookumpucky, I thinned some peralkatone down with some paint thinner, and I've been spreading on everything. I coated that, both the nut, the shaft, the hole, everything with peralkatone. I've got it inside this spring, and then I've coated outside of it with a thinned layer of peralkatone, and so hopefully that'll protect it from rusting for a couple of years. Did the same thing with these worm screws here, these hose clamps. I went over it several times with a thin layer of peralkatone just so it makes sure it runs down into all the crevices and cracks, and I've done that on some of the other things that I put in here. It's like these fair leads that I put on and stuff like that. I make sure they're all coated good with a liberal coating of peralkatone to keep the moisture off of them.